Hi everyone, my name is Ailie Pilecki and I am here to present about Panos Louridas algorithms, which was published in 2020 for the MIT Press Essential Knowledge series. This book is a non-technical approach to algorithms explaining not just what they are, but how they work, which Louridas believes is especially crucial in today's day and age. I transparently was very excited to read this, as I currently work in sales support at a big tech company, and we talk quite a bit about our algorithm. Yet prior to this book, I had a much harder time articulating exactly what we were selling. The work is structured in 6 chapters with an introduction and a closing, and each chapter builds on the previous concepts introduced. Louridas' language is straightforward, and he puts a particular emphasis on examples that someone non-technically minded is able to access and understand. For example, I was particularly excited to find the definition of an algorithm in the glossary. The way this definition is structured shows Louridas' fun approach to the topic and lets you see the enthusiasm he has for it because he's positioned this as a meta definition. As we'll discuss in a few slides, an algorithm is a set of steps to solve a problem effectively. So in the glossary, someone has the problem of not understanding the term, they've gone to the glossary to find the answer, and Louridas has them repeat the steps of reading the book to understand. In the preface, we get the outline for the book as well as why he's writing this in the first place. The main purpose is to make sure that a non-technical audience is able to understand what an algorithm is and why there is so much opportunity when leveraging one. He provides a number of focusing statements in this preface. For example, Louridas believes we live in the best period of human history, driven by lots of technological progress, but it's no longer just enough to use the technology. We must be able to understand it. And this is something that he points to happening a number of times in human history, in that what we need to know changes through time. We have reached a point in time, in his opinion, where algorithms are inside the core of what we consider to be essential knowledge, and if we do not understand how they are working, we're not able to be effective citizens. Granted, algorithms can get quite technical quite quickly, which we'll discuss in a few chapters, but one of his main points is that anyone can learn to write an algorithm, even with pen and paper. He believes that it's not only crucial as someone in a society that relies on algorithms to understand, but it also provides a useful mental tool to solve personal problems. In Chapter 1, we discuss what an algorithm is exactly. Algorithms predate computers. We see examples of algorithms even as far back as ancient Babylon. However, we still speak with them with an almost otherworldly, unknowing, and air of mystery. Louridas believes that algorithms are not mysterious, and they are straight-up tools that solve our problems. He notes, we know exactly the rules that it follows and the steps that it takes, which really is probably the most straightforward thing that we could say about a tool that we're using to solve a problem. He argues that once you understand what an algorithm is, it will no longer seem mysterious, and there are plenty of applications that you can use in your day-to-day. He provides a couple of examples in this chapter where you are able to write your own algorithms with pen and paper. The first example ends up being a way for someone to write rhythms via an algorithm using X's and dashes. And the way that the algorithm is quote-unquote solved is via columns and doing a few simple math problems. He also discusses Euclid's algorithm, which is the way to find the greatest common divisor between two numbers. I've listed this out here on this particular slide because it is a good example of a control structure of an algorithm, which basically means the steps that one goes through in order to solve it. An important distinction in this first chapter too, which I believe he called out before we started getting into the technical bits of what an algorithm is, in order to better understand that part, is that algorithms are not explicitly about computers. Algorithms are often coupled with computers because we can program a computer to do certain things. However, the algorithm itself is something that exists on its own. Programming translates an algorithm so that we can factor in things like speed to execute the algorithms more effectively, efficiently, and make them exponentially more powerful. An algorithm exists because it does something useful and practical. And you'll find throughout this work that Louridas places a big emphasis on the element of being practical and useful. On this slide, I've listed out characteristics that algorithms must meet, such as steps must terminate, steps must be precise, they operate on some input, but that is not necessary. It generates an output, which is the whole purpose, and again, it must be effective. At the end of the day, Louridas believes that a human should be able to execute each step of in a reasonable amount of time with pen and paper. Chapter 2 introduces the first concept in a technical way that makes up what an algorithm is. He discusses the Kronosberg bridge problem, which was how scientists originally understood the study of graphs. A scientist was trying to figure out, how can I get through the city of Kronosberg with crossing each bridge, there were 7, only once. Turns out there wasn't a way, but in figuring this out, the study of graphs was created, which is a set of connecting nodes and edges to model any kind of link structure, from people to a computer network. Many problems are modeled as graphs, and then algorithms are developed to work on top of them. Something interesting about graphs is many things can be defined as a graph. A social network, for instance, such as who you know in your day-to-day, the web, and Louridas goes through a number of examples to illustrate how ubiquitous a graph can be, even without layering an algorithm on top of it. There is an algorithm that uses a graph to outline the first DNA sequence. Graphs can help you find something called the shortest path, i.e. figuring out how to get from point A to point D as quickly as possible. But ultimately, Louridas stresses that with this particular chapter, it is up to us to make sure we're using the right tool for the problem. The next chapter discusses searching, which Louridas says it is unlikely you'll be able to find any computer program doing anything useful without employing algorithms for searching in data. A search algorithm helps us make sure that we're operating with speed and scale, and he discusses a number of different search algorithms in this chapter, which I've outlined here. A lot of these make sense via the name, such as linear or sequential search. We're going to check 1, 2, 3 until you reach 4, versus self-organizing search, where you move the number you're looking for to the front or move it to a certain particular point in the transposition method. We also discuss binary search in this chapter, which works on ordered data, so you're not going back and starting at the very beginning every single time you're searching for something. But ultimately, in this chapter, we also discuss when we know it, or rather, when it's best to stop at the search and make a decision. In order to leverage search correctly, such as when you deploy binary search, Louridas emphasizes that sorting is particularly important. Sorting is so ubiquitous in today's day and age, it's largely invisible, and Louridas discusses the number of different ways algorithms can sort through data so that we're, again, finding what we need in a way that is straightforward and non-complicated. I've listed a number of the different sorting methods here, such as selection, insertion, radix, quick, and merge. Chapters 5 and 6 build on the following, or the previous concepts, even more so. However, they do get quite complicated. This is where I found some of the concepts a little bit over my head as someone with truly no technical knowledge. However, I could appreciate the language that was being used to discuss these concepts, as well as the implications that each of them have. PageRank, for instance, is a graph-based theory that built Google's search engine, which measures a site's importance not just by the content, but also by who is writing it and how many links other sites send to it. This is a good example of the transformative power of an algorithm. Deep learning builds on this idea, where we leverage algorithms to answer amazing problems presented by humans in every single day. And he makes the argument that AI and deep learning are not meant to replace or copy human nature, but exhibit useful behavior. Overall, it was a bit harder to find critical reaction to this particular work, as it is a newer publication, and I believe because it is meant for non-technical audiences. However, it was deemed successful by a number of professors and reviewers in academic journals who called it refreshing and an instructive first book on what algorithms are and how they are used in ways that affect readers' own lives. I thought it would be pertinent to check public reception, as the target audience is not academic, and found that it was fairly well reviewed on Goodreads and Amazon Books. I believed that this particular work was very effective in what it set out to achieve, such as making someone like me, who again is not quite technical, understand the basis of an algorithm as well as the power. However, I didn't find myself nearly as optimistic as Louridas does, because with this power comes great responsibility, to paraphrase a famous quote. Key takeaways for me include the following. Algorithms are tools prioritizing usefulness and practicalness. How best can we manage complexity without overwhelming the user trying to do so? This is something important to think about when considering building an algorithm and its purpose. I agree with Louridas that it is pertinent to understand how our algorithms work, since so much of our current innovation in day-to-day applications involve them. Anyone can literally write an algorithm using pen and paper, and we use them more often than not. And then finally, a key question that I had when finishing this book: what are the implications of a society that can better understand algorithms? What are the good ones and what are the bad ones? Louridas is particularly inspired by the opportunity and creativity that better understanding of algorithms brings, and I believe that, but I also urge everyone to exercise caution when considering the benefits an algorithm could bring, in that we don't want to be training or building algorithms off of intentions that are not explicitly helpful. Thank you.